So as I'm sure all of you know, these are the voltage divider and current divider equations. More voltage will be on the resistor with more resistance, and more current will be on the resistor with less resistance. So, when we assume that R2 is much greater than R1, usually about a factor of 100, I'd say is a good value to just know that if it's greater than 100 or less than 100 times greater than what it's in reference to, then you can use these assumptions. So if we assume that R2 is much greater than R1, we can just do a limit as it goes to infinity, assume it's kind of infinite comparison, and then we get 1 for a voltage divider if we're measuring across that resistance. If we're measuring across the other, it obviously would be 0. Now if we're doing the current divider, if we assume that R2 is infinite, then we get infinity on the bottom, and the limit just comes out to 0. Similarly, when we apply that to just like our voltage divider equations and current divider equations, we get that V out equals Vn if we assume that this is much greater than this, and the current running through here is 0, and the current through here is I1. So now when we put some numbers to this, and we use 100 ohms and 100 kilo ohms, a difference of about 1,000, and we do the voltage division, we see that this actually comes out to 9.99 volts, which for all intents and purposes, we might as well just call it 10 volts. The difference is very small. It's like a 0.1% difference. And similarly for the current divider, if we're measuring for this current, the current on this 10K compared to this 10 ohms is 0.01 amps. Again, 0.1%. And we might as well just call that 0.